Adding Tesla semis to our lineup allows us to expand that across more lanes and operating conditions to evaluate whether heavy-duty electric vehicles meet the same standards for safety, reliability, and performance across our existing fleet. That was how Matt Godfrey, president of ABF Freight, explained ArcBest's decision to add more Tesla semi-trucks to its fleet in 2026. The move came after thousands of miles of real-world testing delivered one of the most impressive Tesla semi results ever recorded, forcing the trucking industry to take notice. Further evidence of Tesla's progress emerged in a June 2026 factory video showing 6 newly produced Tesla semi-trucks, including 4 standard range models and 2 long-range versions. The presence of both variants suggests Tesla is actively scaling production while preparing to serve different freight markets, from regional delivery routes to long-haul transportation. More importantly, the truck's efficiency results have been equally impressive. During its evaluation program, the Tesla Semi recorded an average energy consumption of just 1.55 kWh per mile over 4,494 miles of commercial freight operations. That number may not sound revolutionary to casual observers, but for trucking executives, fleet managers, and competitors, it changes the conversation entirely. Tesla had previously targeted around 1.7 kWh per mile, making the 1.55 kWh result even more impressive. Why? Because Tesla itself originally targeted around 1.7 kWh per mile when the Semi entered production. Later, major fleet trials conducted by DHL and Saia reported results of approximately 1.72 and 1.73 kWh per mile. Those figures were already considered industry-leading. Yet ArcBest's latest result pushes efficiency even further, improving on previous benchmarks by roughly 9%. So what changed? Did Tesla suddenly install a larger battery? Did ArcBest conduct the test under ideal laboratory conditions? Not at all. The most impressive aspect of the result is where it was achieved. The Semi was not driving around a closed test track on a perfect sunny day. Instead, it was performing exactly the type of work that trucking companies care about most. Over the course of the evaluation, the truck traveled between Reno and Sacramento, operated throughout the San Francisco Bay Area, supported rail freight activities, and averaged more than 320 miles per day. These are demanding commercial routes where efficiency gains are difficult to achieve and easy to lose. A major reason for the Semi's performance is its aerodynamic design. Traditional diesel trucks are essentially large rectangular structures pushing through the air. At highway speeds, aerodynamic drag becomes one of the biggest consumers of energy. Tesla approached the problem differently. The Semi's streamlined nose, curved surfaces, and optimized airflow reduce resistance significantly. The result is lower energy consumption mile after mile, especially during long-haul operations where efficiency matters most. But aerodynamics alone do not explain everything. Tesla's powertrain technology is another critical advantage. Unlike traditional truck manufacturers that often rely on multiple suppliers for major components, Tesla develops its motors, software, battery systems, and control architecture as a unified package. This allows the truck to continuously optimize energy use in real time. Every acceleration, every climb, and every change in terrain is managed by software designed to maximize efficiency while maintaining performance. And then there is the mountain test that caught many people's attention. ArcBest drivers reported strong performance while crossing Donner Pass, one of the most challenging trucking routes in the western United States, rising to roughly 7,200 feet above sea level. The pass is known for steep grades that place enormous stress on conventional trucks. Diesel engines consume large amounts of fuel during these climbs and waste significant energy on the descent. The Tesla Semi approaches the challenge differently. Its regenerative braking system converts downhill momentum back into usable electricity, effectively turning part of the mountain into a charging opportunity. Yet perhaps the most surprising takeaway was not the efficiency figure at all. It was the reaction from the drivers. Fleet operators know a simple truth: a truck that drivers dislike becomes a truck that sits idle. Performance specifications look great on paper, but driver acceptance determines whether a vehicle succeeds in the real world. According to ArcBest, drivers consistently praise the center seat driving position, exceptional visibility, intuitive controls, and overall comfort during long shifts. Similar feedback has emerged from other operators, including Covenant Logistics, whose drivers were reportedly amazed by the Semi's ability to climb California's infamous grapevine grade with ease. If Tesla Semi is truly more expensive than a diesel truck, then why are so many fleet operators suddenly rushing to place orders? More importantly, why did California decide to launch an entirely new incentive program just as Tesla Semi entered mass production in 2026? The answer may reveal something much bigger than a single electric truck. For years, Critics argued that the biggest obstacle facing electric freight transportation was the high upfront cost of the vehicles. On paper, they appeared to have a point. A Tesla Semi carries a purchase price of roughly $290,000, significantly higher than many conventional diesel tractors. However, a growing body of financial data suggests that looking only at the purchase price may completely miss the bigger picture. According to a recent total cost of ownership analysis published by Electrek and supported by Bernstein Research, the economics of the Tesla Semi are becoming increasingly difficult for fleet operators to ignore. Using a Tesla Semi long-range priced at approximately $290,000, the analysis estimated that operators could save anywhere from $147,000 to more than $400,000 over 5 to 10 years, compared with a comparable Freightliner Cascadia diesel truck, depending on electricity prices, diesel costs, and operating conditions. Under assumptions of electricity costing around $0.12 per kilowatt hour and diesel averaging $5.35 per gallon, the Tesla Semi's total ownership cost over 10 years was estimated at roughly $795,000, compared with nearly $1.2 million for a diesel alternative. Those findings help explain why companies such as Big F Transport have committed to ordering dozens of Tesla semi-trucks. The decision was not driven by enthusiasm for Tesla or electric vehicles. It was driven by economics. At a certain point, the financial advantages become too significant to overlook. But the story becomes even more interesting when California enters the equation. On May 13, 2026, California officially launched the Clean Commercial Freight Rebate CCFR program, backed by a $250 million budget for 2026 and a long-term commitment of $1 billion through 2030. Applications are scheduled to open on June 26, 2026, almost simultaneously with Tesla semi-mass production deliveries from Gigafactory Nevada. Many observers immediately asked a reasonable question: why create a new incentive program when California already had HVIP, one of the country's best-known electric truck incentive programs? The answer lies in what happened between January 2025 and February 2026. During that period, California received 1,067 voucher applications for Class 8 electric trucks. Remarkably, 965 of those applications were for Tesla semi-vehicles. Daimler, Volvo, and PACCAR combined accounted for fewer than 100 applications. The imbalance became impossible for regulators to ignore. California Air Resources Board officials eventually removed a manufacturer cap that had previously limited how many incentives a single company could receive. The official explanation was that the restriction prevented customers from purchasing the vehicles they preferred. Critics, however, argued that the system increasingly favored Tesla semi-applicants. Ryan Truck USA CEO Alexander Vowitz publicly criticized the structure, arguing that competing manufacturers often had trucks available for delivery but were disadvantaged by the way incentive funding was distributed. Rather than continue modifying the existing system, California introduced CCFR as a new framework. Unlike HVIP's first-come, first-served structure, the new program allocates funding based on specific freight use categories, including port operations, regional haul routes, and urban distribution networks. Tesla Semi remains eligible across nearly all of those categories. This is where the economics become especially compelling. When HVIP and CCFR incentives are combined, some qualifying fleets could potentially receive support worth as much as $360,000 for a truck with a purchase price of roughly $390,000. In certain qualifying scenarios, the available incentives can exceed the vehicle's sticker price. Now consider a fleet operating 20 diesel trucks at the Port of Oakland. California continues to have some of the highest diesel prices in the United States, creating a significant operating expense for freight companies. Fuel costs alone can consume hundreds of thousands of dollars annually and, for heavily utilized fleets, may exceed $1 million per year. Switching to Tesla Semi not only reduces energy costs substantially, but also lowers maintenance expenses while dramatically reducing the effective purchase cost through available incentives. That is why the real question facing fleet operators may no longer be whether they can afford to switch to electric trucks. Instead, the question is becoming whether they can afford not to. And judging by the 965 Tesla Semi applications already submitted, many companies appear to have reached the same conclusion. Why can't competitors keep up? When examining today's competitive landscape, it becomes clear why fleet operators are increasingly turning to Tesla Semi. The combination of battery technology and driving range offered by traditional truck manufacturers simply cannot match Tesla's engineering approach. One of the clearest examples is battery utilization. Recent regulatory filings from the California Air Resources Board revealed that the long-range Tesla Semi uses an 822 kilowatt-hour battery pack while maintaining a rated range of approximately 500 miles at the maximum legal gross combination weight of 82,000 pounds. By comparison, the Freightliner eCascadia offers a typical range of up to 230 miles, while Volvo's VNR Electric is rated at approximately 275 miles in its current configuration. Even though those trucks use battery packs exceeding 500 kilowatt-hours, neither comes close to matching Tesla's long-haul capability. This gap matters because freight companies do not buy trucks based solely on battery size. They buy productivity. A truck that can cover significantly more distance between charging stops can complete more revenue-generating work during a driver's shift. Every additional stop adds downtime, route complexity, and infrastructure requirements. Tesla's advantage extends beyond range. The company has built the Semi around an integrated technology stack that includes its own battery technology, power electronics, software systems, thermal management architecture, and charging ecosystem. Unlike many traditional manufacturers that adapt existing diesel platforms for electrification, Tesla designed the Semi specifically as an electric truck from the beginning. That approach allows engineers to optimize every component around efficiency rather than compromise around legacy vehicle architecture. Charging capability is another area where Tesla is pushing ahead. The Semi supports charging rates up to 1.2 megawatts through the Megawatt Charging System standard, allowing operators to recover a substantial portion of range during mandatory driver breaks. Few competing Class 8 electric trucks currently operate within a charging ecosystem of similar scale and power. The most compelling evidence, however, comes from the market itself. Major logistics companies are not simply testing one or two demonstration vehicles anymore. Fleet operators are beginning to make meaningful investments. Companies including DHL, Seva Logistics, Watt EV, and ArcBest have all expanded their involvement with electric trucking programs, with several specifically incorporating Tesla Semi into their long-term plans. Perhaps the strongest indication of Tesla's lead is that the conversation has changed. A few years ago, industry discussions focused on whether an electric truck could realistically handle heavy freight operations. Today, the debate is increasingly centered on whether competitors can close the gap Tesla has established. When an 822 kilowatt-hour battery can deliver a workload that previously seemed to require a much larger pack, it suggests Tesla's advantage is not simply battery size. It is the efficiency of the entire system working together. That is why many fleet operators are paying attention. The challenge facing Tesla's competitors is no longer building an electric truck. The challenge is building one that can match Tesla's combination of range, efficiency, charging performance, software integration, and real-world productivity all at the same time.